Hi there, as a part of AgilePoint's version 10 release, we're happy to announce support for Google Gemini. Over the course of this video, we'll show you how to leverage the Gemini AI Control Tower activities as a part of a sample application. If you're interested in learning how to create an access token for Gemini, please watch the companion video. Now we'll walk through the application in just a moment, but first let's understand the Gemini Control Tower activities. So as you might have seen with other AI platforms, there are a couple of major categories: analyze image and chat completion. But within each category you're seeing here, we can layer in dynamic process behavior. One being leverage analyze image to adapt the flow, where we change the typical processing, injecting an ad hoc task, initiating sub-processes, and sending notifications. And similarly, the same actions are available under chat completion. Now for today's use case, we have an insurance claim application where we have a number of the typical insurance claim processing steps, where a customer has an accident and calls into a call center to initiate a claim, a step where the customer receives a task to provide images of the damage shown to their vehicle and additional descriptions around the accident, and further internal processing. Now across the top, we have 3 Gemini Control Tower agents. We have an image classification agent, which will analyze the customer provided image showing damage to the vehicle, which will hand its insights over to our claims analyzer agent, who will take the inputs from our image classifier and compare that against the customer provided description of the accident. Now these 2 agents will hand their insights over to our final fraud predictive agent, where in the event that fraud is likely, we'll see the typical processing paused and additional levels of review injected for our fraud investigation team. So let's walk through a couple of our agents, starting with the image classifier. So as you're seeing here, this is using the analyze image activity. Now the image will be provided by the customer and uploaded through the AgilePoint form. So we're going to retrieve the image from the document repository. In this case here, you're seeing that we're using Box, but any number of out-of-the-box repositories will be supported. Okay, that brings us to the model configuration. So first, I've connected to Gemini using the access token. Next, I've selected the model that I'd like to use. You're seeing here that I do have the option to use the model configured in the access token, though I do have the option to select from the various models here. Moving over to the system instructions, you're seeing here the goals are to analyze the image of a car that's been in an accident, to determine damage on specific parts of the vehicle, and to return a structured damage assessment. So what the model is going to do here is analyze the image and for various portions of the car, determine whether that portion was damaged or not. The skills include computer vision-based image analysis, damage detection, visual inspection and classification, as well as structured data generation. So in this case here, JSON formatting. And to make a decision, yes or no, as to whether a specific part of the vehicle has been damaged. Now the context or the input is going to be the image provided by the customer. Various instructions. So as we just discussed, we need to determine whether specific portions of the vehicle have been damaged. And you're seeing those listed here, as well as a number of rules to follow. Now you're seeing here, there are quality verification steps. We need to determine all 9 parts of the vehicle are present in the image and whether they've been damaged. And then the output being a JSON structure, and as you're seeing here, I have prescribed the schema. Now in the case of Gemini, we do have safety settings. As you're seeing here, this has not been configured. But moving next to our triggering event. So one of the big differences between having a control tower versus process activities layered directly into my process is that the control tower is event driven. So here you're seeing I'm going to have this model kick in when the customer engagement step has been completed, and I can bring in additional filter conditions. Now, nothing here from a request mapping perspective. We are passing the entire image from the form. And the response here, as you're seeing, has been mapped to my application schema. So what you're seeing here are all of the different portions of the vehicle where we'd like a damage assessment performed. And we're mapping that back to the relevant nodes here in my application. Now, no parsing required in my case, though if I had sort of saved this to a variable, I can leverage things like inline functions, regular expressions to parse out specific elements. And no actions in this case here. We're just getting the values returned from my vision model. Okay, now for our two remaining agents, the configuration is pretty similar. Let's go ahead and take a look at the fraud predictive agent because it will bring in dynamic process behavior in the event that fraud is likely. So again, connecting into Gemini, the model, and moving into system instructions. As you're seeing here, this is really all about analyzing the bigger picture of our insurance claim as a whole to determine whether fraud is likely. So you're seeing here, looking for anomalies, inconsistencies, unusual patterns and risks, things of that nature. From a skills perspective, we're leveraging insurance domain knowledge, fraud pattern detection, financial risk analysis, and so on. Various inputs from the policy itself. Instructions, quality verification, and of course the output. So here we're bringing in some guardrails around how we determine fraud, and you're seeing that here on screen. So again, I have a triggering event. In this case here, my control tower will fire when the milestone activity has been completed. And again, additional filters can be brought in. Now, from a request mapping perspective, you're seeing here AgilePoint has intelligently brought over the JSON structure from my system instructions, which means it's now a very straightforward mapping. Similarly here, from a response mapping perspective, what we're expecting back is a fraud prediction and probability. Again, no parsing required in this case. And then finally, the actions. So in the event that fraud is likely, we're going to see a sub-process dynamically invoked. And let's go ahead and take a look at the conditions. So as you're seeing here, if we are suspecting fraud and the probability is greater than 50%, or we find that the insurance claim report itself was not submitted by a human, perhaps submitted by an LLM or some sort of fraud, and whether there are key conflicts. Say, as an example, a key conflict might exist between what's shown in the customer provided image and the accident description provided by the customer. So these are our guardrails and rules that are going to drive that dynamic behavior. So now that we've taken a look at the various control towers, let's go ahead and run this application. To get our process started, I'm going to play the role of a call center employee. A customer has just had an accident, and what I'd like to do is open up the claim. So first, I've retrieved their policy ID from our policy management system, and we'll set up some of the initial details of the claim, including the vehicle involved, the driver's name, capture the accident details. Now recall, we'll have the customer provide more context around the accident as the next step. Various witnesses, the third party involved, prior claim history, and lastly, leave a comment and open up our claim. Okay, so our process has just kicked off, so let's go ahead and track it. So now we're sitting with the customer. So if I move into my inbox. Okay, so playing the role of the customer, here I'll provide more context around the accident and supply an image showing the damage to my vehicle. Okay, so here's the image we're going to use. Pretty clear damage to the front of my vehicle. So let me quickly upload that. Now, while that's uploading at the bottom, a more detailed accident description. So what I'd like to do is introduce very clear conflict between what's shown in the image and the description. So we'll make a small change here, indicating the back of the vehicle has been damaged. Okay, so as a next step, we're going to start seeing our various control tower agents light up, starting with our image classification agent, the claims analyzer agent, and finally, our fraud predictive agent. Now, in the event that fraud is likely, we're going to see the typical processing paused and new steps added into the application for additional review. Okay, so all three indicators have now lit up, which means if we go check in on our task list, you're seeing here we have the typical next step as shown in our process map, which is with the claims handler. However, the typical processing has been paused. So as I try to open this, I'm going to be met with a warning indicating that fraud is likely in this claim with a certain confidence level and that the typical processing has been paused. So we're seeing that here. Meaning I can go back into my task list and assume the role of a subject matter expert. A task has been dynamically routed to me, indicating fraud is likely in this claim. So what you're seeing here is though AgilePoint can operate autonomously, we're bringing a human into the loop to review all of the insights that AI has uncovered. So we have that now on our form. There's the image that we provided previously. There is the damage assessment. And of course the outputs from our claims analyzer agent. So we're seeing here pretty high certainty that fraud is likely in this claim. The report or the claim is authentic from a human. No LLM has submitted this here. But there are some pretty clear conflicts, right? As we discussed earlier, the image showed damage to the front of the vehicle, whereas the description indicated the back of the vehicle had been damaged. And then lastly, I can use all of these insights and my expertise to determine whether I should accept the suggestion made by the control tower. And that is, again, to stop the typical processing and bring in additional levels of review. So I'm going to go ahead and accept that suggestion. I want to assign the newly inserted task to myself, and I want to keep the lock on all of the downstream steps. Okay, so now behind the scenes, the AgilePoint engine is dynamically injecting another new step into our application that we did not have during design time. And we're seeing that sit with me now. So now I'm going to play the role of a fraud investigator. Again, all of the insights that AI has uncovered are now presented to me here in this form. We're going to go ahead and skip over to the investigation tab, where I'll take an offline action to review and validate the fire and police reports and make a determination. Now, in this case here, I could reject the claim, but in my case, using my expertise, this is a customer who is just a bit frazzled after having had an accident. So I'm going to go ahead and allow this claim to proceed further. Okay, so in closing, I hope this gives you a better understanding of how to leverage the various Gemini AI Control Tower agents. One last thing I'd like to add in closing is that whenever an agent takes action against our application, AgilePoint provides complete audit trail of all of those actions. So as an example, moving into my process viewer, you're seeing here, I can always investigate the details of why a control tower took action and the actions that it took. So all of the input and output data as well. And this is also available in textual format. So here in the Manage Center, looking in the details of this particular instance, you're seeing here I can always investigate all of the details of each agent. Okay, so with that, that's going to conclude the content for this video. Thank you so much for watching. Until next time.